Hey everybody, in this video we're going to be looking at solving a quadratic equation in vertex form. And now this is the first place where we're going to put all of this together that we've learned in Module 7. We know that by looking at a graph we can identify these roots, the solutions. So in this case we already know our answer. Our solutions are x equals 1 and x equals 5. So the question is, how do I go from this equation, which is in vertex form, how do I use a square root, which is what we just learned about, in order to find those two? And so that's what we're going to look at. How do you take something in vertex form, use everything we just learned about a square root and everything we know about solving equations to get to this information right here without having to have the graph? So here it goes. First thing we have to do is really think about what we're doing when we're solving a linear equation. And so you can see this equation right here is linear. There's no squared terms in there. And what we would do is we would take the order of operations and we would work through it backwards. So when we're evaluating, we start by doing things in parentheses and then moving down towards addition and subtraction. When we're solving, we're going to start with addition and subtraction and work our way toward the parentheses, and we're undoing each operation with its inverse operation. So we start by looking for any addition and subtraction in the equation. And I've got subtraction right there, but it's inside parentheses, so we'll wait for later. And here I've got subtraction of this minus 8. So the first thing we're going to do, and we're not even going to solve this, like I just want to right now write down what steps we would do. The first thing we would do is we would undo subtracting 8, which of course we would do by adding 8. Then we would look to undo any multiplying or dividing. So next we would undo multiplying by 2. So this 2 out front is being multiplied by that whole quantity right there. And so I would undo multiplying by 2 by dividing by 2. And then after that, I would undo the subtracting by 3. And it comes last simply because it was in parentheses. Well, we've added something to this now with the square root. So if we look at an equation where we have a squared term in there, like I would in vertex form. This is just a quadratic equation in vertex form. I have this step of taking a square root. And since this is the inverse operation of an exponent, it's going to happen in this step right here between multiplication and division and where the parentheses are. So if I look at my steps to solving this equation, the first thing I do is undo any addition or subtraction. So in this case, I would undo the negative 8. And then I would undo any multiplication or division. So I would undo that multiplying by 2 that's happening right there. And then after that, I would want to look to undo any exponents. So now I would undo that raising to the second power that we see right there. So that right there is the step where I would take my square root, and then the very last thing I do is undo anything in parentheses. So in that case, that's the minus 3. So now let's put it all together and let's look at what this looks like. Remembering, there's so much information here, remembering that when I take the square root, I'm actually going to get 2 answers, which splits my problem into 2 parts. My goodness, there's a lot going on here. So let's look at this equation. It is in vertex form, and let's look at how I would solve it. The first thing I would do is undo subtracting 8 by adding 8. And I should go back here and say, notice what this is equal to. This is equal to 0. When I'm solving a quadratic, I always want it equal to 0. So don't let that slip by us unsaid. So now I've undone that adding 8, so I would get 2 times x minus 3 squared equals, well, 0 plus 8 is 8. Now I need to undo multiplying by 2, and to undo multiplying by 2, I would divide by 2, and so here I would get x minus 3 squared equals 4. Now I need to undo any exponents. So to undo squaring, I'm going to take the square root of both sides. So the square and the square root cancel each other out, leaving me with just x minus 3. And over here, the square root of 4. Well, aren't calculators just the handiest? So I can come over here, and once my calculator is working, I can ask it to take the square root of 4 for me, and I get 2, but I have to remember that that's only the principal square root. It could be positive 2 or it could be negative 2. So watch what happens. I have to split this now into two problems. It could be that x minus 3 is equal to positive 2, but it could be that x minus 3 is equal to negative 2. I have to account for both options. And so when I do that, now I just undo the subtracting 3. 2 plus 3 is 5. So one of my solutions is that x equals 5. Over here, I do the exact same thing, but now negative 2 plus 3 is equal to 1. And so my solutions to this are x equals 1 and x equals 5. Now if you remember, very first thing we looked at with the graph of this, we said the answers were going to be 1 and 5. So that's very reassuring that we can see this process actually works. So again, just to oversimplify, undo the part that's added or subtracted at the end, k. Undo multiplying by this number. Then take your square root, which splits it into two possibilities. It could be the positive square root or the negative square root. And then undo whatever's inside the parentheses last, and we have our two answers. So let's look at a couple of example problems to make sure we're on top of this. Excuse me. So here I go. It's equal to 0. I'm ready to go from there. The first thing I'm going to do is undo any addition or subtraction, and that leaves me with this situation. Now I undo the multiplication, so I'm going to divide both sides by 2, and I get x plus 13 squared is equal to 9. Now, in order to undo that square root, I need to take the square root of both sides, and from here my problem is going to split into 2. I can find the square root of 9 on my calculator. The square root of 9 is, of course, 3. And so what I can say is that the square root of x plus 13 squared, well, that could be x plus 13, and it could be positive 3, the principal square root, or it could be negative 3. And now I have to solve both of those. So I would subtract 13 from both sides and get x equals negative 10. Over here I would subtract 13 from both sides and I would get x equals negative 16. And those are my two solutions. X equals negative 10 and x equals negative 16. If you really want to push it, you can go into Desmos and graph this and verify that those are actually the answers. But there you go. Go through the order of operations. Remember that you're going to have a positive and negative value for the square root, and go from there. So I've got two more examples for you. Let's look at what happens when we get an irrational number on this, which is what will happen the overwhelming majority of the time. Start by undoing any addition or subtraction. And so I get x plus 5 squared equals the square root, or not yet, getting overly excited, 39. Now, to get rid of that squared term, I'm going to take the square root of both sides, and the square root of 39, when I go ahead and put this in my calculator, it does not come out even. That is an irrational number. It never repeats. It never ends. And so what I need to do is I need to find the prime factorization of 39 and see if I can simplify that radical. So I try 2 first, and that doesn't work. and then I try 3. Whoa, and I tried 3 badly apparently. There we go. And I find that that's 13. So the square root of 39 is the square root of 3 times 13. There's nothing that repeats in there. So there's no way I can simplify this. So I can say that x plus 5 is equal to the square root of 39. That is as simple as it gets. But remember when I said this splits into 2 problems? That could be positive 39, or positive square root of 39, or it could be negative square root of 39. When it is in a radical like this, typically the way we will write that is to say plus or minus the square root of 39, and just leave it at that, knowing that it could be positive or negative. Now I get to my last part, and I want to subtract 5 from both sides, and I get x equals plus or minus the square root of 39 minus 5. I can't simplify that at all, so I just leave it as is, and that is my answer. And it includes both answers, because this could be, if I wanted to write it out this way, even though it's kind of a pain in the neck, x could be the square root of 39 minus 5, and it can also be negative the square root of 39 minus 5. But this way of writing it just makes it a little easier to see. Looking at a third and final example, it's equal to 0. That's great, so I'm going to start by getting rid of the addition or subtraction at the end. So I get negative 9 equals 3 times x minus 4 squared. Divide both sides by 3 because I want to undo any multiplication next. Now I want to take a square root, and so that leaves me with x minus 4 on this side. But notice this is the square root of negative 3, and remember what happens if we try and take the square root of a negative number? Well, that is going to give me no real solution. And so I have no answer to this other than to say there are no real answers. I would have to get into imaginary numbers to get that, and we are just not going to go there, friends and neighbors. So there you go. That's it. If you can remember and practice that process, you'll be able to solve, that is, find the x-intercepts of any quadratic equation you see in vertex form. Practice hard and good luck.